Okay, for this set of notes, it's a lot like square roots, except the root is bigger. And so, remember with square roots, we were looking for 2 of a kind. If the root is bigger, you're just looking for that many of a kind. All right? So, in number 1, because the root is a 3, that means when we break down 54, we're looking for 3 of a kind. Well, I know that 6 times 9 gives me 54. And 6 breaks down into 2 and 3, so I'm done with the 6. And 9 breaks down into 3 and 3, so I'm done with the 9. And again, because the root is 3, I'm looking for 3 of a kind. And now that I have circled, I get to pull out a 3. Anything that I did not circle goes back under the radical. Make sure it is still a cube root, and then the 2 goes back under. Okay? So with number 2, we have to figure out what gives me 81. 9 and 9. And each one of those is a set of 3s. But the root this time was a 4, so I need all 4 of them. That only makes 1 circle. So I get to pull out 1 3, and there's nothing left over. That's it. That's the final answer. Okay? And of course with letters, just like with the square roots, we're doing the same thing. So we're looking for 3 of a kind or 4 of a kind or however many. All right, so in number 3, we're looking for 3 of a kind. All right, and I'm going to start with 4. So I just did 92 divided by 4 on my calculator and got 23. 23 is prime, so that one's done. But 4 gives me a 2 and a 2. However, I do not have 3 of a kind, and so 92 is going to have to go back under my radical. Remember, it's a cube root. But look at your letters. Just like with square roots, we divided by 2 to see how many we got to take out. With a cube root, we're going to divide these by 3. So, then figure out how many are left over. So 3 goes into 3 once, so I get to take out 1 u, and there's none left over. And then 3 goes into 10 3 times, so I get to take out v to the 3rd, but that only uses up 9 of them, so there's 1 left over. Okay? Let's keep working. See how we do. All right, number 4. 5 does not break down except 1 and 5. And according to this root, this radical, I need 5 of a kind, and that's not it. So when I finish, the 5 is going to go back under my radical. Don't forget it's a 5th root. Now, if I look at a to the 5th, I have to figure out how many sets of 5 can I make out of that, and I can make 1 set. And there will be none left over. Then I look at b to the 9th. Well, I can make 1 complete set, but there will be 4 left over, so that goes back under. And then I do the same thing with the c's. Well, 5 goes into 13 twice, but there will be 3 left over. Remember, you don't have to write the ones, but if you want to, you can. All right, let's change colors. In number 5, we have a multiplication. So just like with square roots, you multiply first. Notice this is actually a square root. All right, 12 times 75 is 900. And then remember, you add the letters, so you get 4 A's and 5 B's. And again, if there's no number in the radical, it's understood to be a 2. Now, yes, I could go back to 12 and 75, or anytime I see something with 100, I do 9 and 100. And I know that they are both perfect squares. So I have a pair of 3s and a pair of 10s, and when I multiply them together, that means I get to take out a 30. Okay? Well, how many times can 2 go into a to the 4th? That would be 2 with none left over. And 2 goes into the 5 twice, but there will be 1 left over. Now, there's no numbers left over, so the only thing that goes onto the square root is a b. Remember, there's no number right here in the radical. It's understood to be a square. All right, and then in number 6, we have a cube root, so that has to stay. Then we multiply 27 times 5. That's 135. Add the exponents, so we get x to the 8 and y to the 4. And then we break it down and look for 3 of a kind. Well, I don't know much about 135, so I'm going to go back to 5 and 27. 5 is done. 27 is 3 and 9. 9 is 3 and 3. And I'm looking for 3 of a kind, so I get to take out a 3. Now, I'm also looking for 3 of a kind in the x's and the y's. Well, I can make 2 complete sets in the x's, but there will be some left over. And I can make 1 complete set out of the y's, but there will also be some left over. Don't forget the radical is a 3. I still had a 5, 2 x's, and a y. All right, and then I'm giving you a few problems that are a little bit harder. I want you to think, all right, what if the problem looked like this? All right, well, if you remember, what does it mean to be a 1/3? We talked about converting before. That would be a cube root. And so I could rewrite it like that and then break it down. Okay? Well, I happen to know that 64 is 4 times 16, and 16 is 4 times 4, so I can actually stop because there's my 3 of a kind. I can make 2 sets of x's, 3 sets of y's, but there will be some left over, and 1 set of z's. Don't forget to rewrite the cube roots. We were done with the 64 and the x. Now, remember we made 3 sets of y's. So that means we only used 9, so there were 2 left. Okay? Number 8, I can do the same thing. A 1/4 power is the same thing as the 4th root, but we have a fraction underneath. And the 4th root means we're looking for 4 of a kind. So on top, there's exactly 1 set of x's with nothing left over. And on the bottom, there are exactly 2 sets of y's. All right, number 9 is completely different because it has a cube root on the top and a 4th root on the bottom. So we actually have to work them separately. Okay, so let's just start with the cube root. That means we're looking for 3 of a kind. 3 of a kind. Well, 24 is 4 and 6, and 4 is a pair of 2's, and 6 is another 2 and a 3. So we do have 3 of a kind. So we get to take out a 2. Now, how many sets of 3 from the m's? Just 1 full set of m's and n's. It's still a cube root. We did not circle the 3. There was 1 m left over and 2 n's. Now, that's just the cube root from the top. And don't forget, there was another 2 on top. So we will multiply that in a minute. All right, now let's look at the bottom. And I'm going to run out of space, but we'll make it work. All right, so on the bottom, we're looking for 4 of a kind. And if you look back earlier, 81 was 9 and 9, and that was a bunch of 3's. In fact, 4 of them, so I get to take out a 3. Now, I can make exactly 2 sets of m's and 1 of n's, and I don't have anything left over. Okay, so now let's rewrite our fraction. On the top, we're going to have a 4. We're going to have an m and an n, and the cube root of 3mn squared. And now the bottom has the 3, the m squared, and the n. And I'd like to think we were done, but we are not, because anything that is not under a radical, if they have something in common, we still have to cross them out. So the n's are exactly the same, so they cross out. And when we subtract the m's, there is 1 left on the bottom. Then you just carry over the cube root as part of your final answer. Okay? So that one took a lot of steps. We just did the top and bottom separately, and then finally put it back together and reduced. All right, in number 10, the way it's written, it's looking for 6 of a kind, and we don't have 6 of anything. So actually you're done, unless I ask you to convert, and then that would be something we learned earlier. That means you would raise what's underneath, in this case to the 1/6. But if I have something like that raised to a power, then technically I can distribute the 1/6. And when I do 2 times 1/6, I reduce and get 1/3. And then for the b, 3 times 1/6 reduces to be 1/2. So just make sure you read the directions. I might ask you to break it down or rewrite it. Number 11, that looks kind of like an old problem we've done, or something we've done before, because you have the same base. All you really need to do is add the exponents, and 1/4 plus 3/4 is 1, and there's nothing else you can do. And then the last one, number 12, it says I'm looking for 5 of a kind. 5 of a kind. So I have enough to make 1 set of x's on top and exactly 2 sets of y's on the bottom. However, I still have 3 x's left over, so they have to go back under the radical, but it's only on top. The radical is gone on the bottom because I used up every single y. And that's it.